Welcome back. We are going to do some constructions, all focused on this theme of putting perpendicular lines through points. And in the last lesson, we learned how to do this one case where you put a perpendicular line through a midpoint. And when you do that, the perpendicular line that goes through the midpoint gets a special name. It's called a perpendicular, I'm going to use the symbol for perpendicular here because I don't want to write the word again, perpendicular bisector. So it cuts the segment in half, it bisects the segment, and when it bisects the segment, it also makes a right angle. And this is the symbol for perpendicular, which means lines or line segments that come together and form right angles. Sometimes you'll put a little right angle symbol there like that. You don't have to, you can just put it like that. That means perpendicular. So as a reminder, I'm going to sketch that construction here. This is what goes in your notes, and then I'm going to do the formal construction on this side. So the construction for perpendicular line through a midpoint looks like this. We take our segment, we go to one side of the segment, we open up the compass some distance that is more than half, and we swing the arc up and we swing the arc down. And we end up putting something that looks like that. So that's step one. Then, keeping the compass locked at that distance, we flip it over, we pin it to this side, we put the center right here, and we make the exact same arc. And that exact same arc goes here. So that is step two. This intersection point and this intersection point get connected. And if we want to show that it's a line and not a line segment, we could put arrows on it. And that is step three. So this is the perpendicular bisector. Let's actually construct that here. Some segment, one endpoint, that's the other endpoint. I center myself on one end, open up more than half, that's good. Put an arc. Flip around to the other side, put the exact same arc. I have an intersection point here, I have an intersection here, I connect these. Perpendicular line, it is going through the midpoint. So right there is our midpoint, and we have a right angle here. We could check to make sure that we have a right angle. It definitely looks like it. We know we did our construction correctly, and just to totally prove to ourselves that we did this right, I'm going to center my protractor at the angle. I line up the 0 with this side of the angle, and then I measure what we constructed, 10, 20, 30, 40, 50, 60, 70, 80, 90 degrees. So yes, this is a 90-degree angle. Let's make it a little more complicated now. And then we're going to take the complicated problem and make it simple. What if we wanted to put a perpendicular line through any point on a segment? Like what if you had a segment here and you wanted to put a perpendicular line through this point right here? It's not the midpoint. It's just some random point that's on the segment. Well, we know how to do perpendicular line through a midpoint. If we could somehow turn this problem into this problem, that would be great because we know how to do this. And that's exactly how we're going to proceed. So looking at this setup right here, when the perpendicular line goes through the midpoint and it bisects the original segment, it takes this segment and it splits it so that you have one piece over here which is congruent, the same as this other piece over here. Within this long segment, there is a shorter segment. Somewhere over here, there's an endpoint where, I don't know exactly where it is, maybe it's about there, maybe it's a little bit further over, it's somewhere around here. There is a segment where this point here is the midpoint of that segment. If I could find that segment, then I could just do my perpendicular bisector construction. So if this point was the midpoint of some other segment, then that would mean this side has to be congruent to this other piece that's over here. This has to be the same as this. That will help me figure out where this unknown point is that will give me my new segment to then do a perpendicular bisector construction on it. I'm going to take my compass, measure how big this segment is, and then just swing around to the other side. Swing it around, maybe I'll swing around the top, and I'll mark something like that. Like I'll trace this around, and I'll find this point over here. And once I find that point, I don't care about this stuff over here. I'm just going to focus on this new segment and do perpendicular bisector through this new segment, ignoring this stuff over here. So here's what that looks like. Here's a segment. Let's say I wanted to go through, let me make this a little longer. Let's say I wanted to go through that point right there. Somewhere over here, it looks like it should be maybe somewhere in this neighborhood. There's another point where if I cut this off, I'd end up with a segment where that's the midpoint. I'm going to find where that point over here belongs. So I go to this point, open up so that I'm measuring this side. I'm going to put a little arc and then swing around to the other side. There we go. When you draw a circle, the distance from the center to the edge, 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 from the center to the edge is always the same. So this is the same as this. I don't care about this stuff over here anymore. I'm just going to do perpendicular bisector to this piece. So I center myself over here, open up more than half. That looks good. Come around to the other side. That's the point I care about now. So I center myself here, swing up, and now I've got an intersection and an intersection. And there we go. Perpendicular line, it's going through this point. Really looks like a right angle. And when I measure it, yep. Oh, there we go. 0 up to 90 degrees. Let's just come back over here for a second and add in the construction marks that we put over here. Let's put them in the notes part. So we would have gone over here, opened up more than half, put an arc, flipped around to this side, opened the exact same distance. We wouldn't change anything. Swing that arc around and then connect those intersection points to make your perpendicular line. Let's make things a little more complicated now and then turn it back into that simple problem of perpendicular bisector. What if you wanted to do a, let's do a perpendicular line through any point whatsoever. It doesn't even have to be on the segment. Like if you had a segment and a point over here and you wanted to put a perpendicular line, so it needs to make a right angle when it passes through this segment. So I need to make a right angle and I need to pass through this point. I'm trying to make this line. How are we going to construct that? Well, the way we can think about it is this line here is the perpendicular bisector to some other segment, to some shorter segment. Like you see how there's this extra distance here? Just like in the previous case, I would like to figure out where to put a point so that I can ignore this stuff on the side and do my really easy, comfortable perpendicular bisector construction. Well, this point, whatever distance it is from this endpoint, if this is the perpendicular bisector, it needs to be the same distance from this point. Same thing goes over here. There's a point over here that's the same distance from there, and it's the same distance from there, but this is the point that we've been given. So we're going to use this point to find this. We're going to use this point and this distance to find out where this other point belongs so that we can do our perpendicular bisector construction. So we're going to put the compass here, open it up to be this distance, put an arc. Step one, we put this arc. When we put this arc in place, it identifies this point for us. And once we have this point, we can just do our perpendicular bisector. I ignore this stuff that's on the side, it doesn't matter. I go to this side, I open up an arc, I flip around to the other side, I open up the exact same arc, so that's 2, this one is 3, and then boom, I connect those intersection points, and I make my perpendicular line that went through this random point that was just sitting there in space. So let's see that with the compass and the straight edge. You have some random line segment, some random point. I'll put the point up here. There's a distance over here, and I want to know where the point is on the segment that is that same distance away. So I'm going to put the turning point here, adjust the compass so that it is that distance. Let's see. Yep, that looks good. Swing around over here. This point is important. This point is important. I don't care about this piece of segment over here. I'm just going to focus on these 2 points, which define a new segment for me, and I can just do perpendicular bisector to this. So I center myself on one end, I open up more than half, I make an arc. You don't have to actually make the arc go all the way. If you want, you could just put some of it down here, and then put some of it up here, and then you could flip around to the other side, put some of the arc up here, put some of the arc down there. If you're doing a really messy construction with a lot of marks, maybe this makes it a little neater, a little easier to see what you're doing. And then I connect through those points, through those intersections. Perpendicular line, it is making a right angle right here, and it is passing through that point. And now the one other variation I want to show you is this exact same thing, but what if you're in a situation where the point you have to pass through is too close to one of the endpoints for you to open the compass? Like the compass has a limit for how short you can make the arc, the radius. I can't push this in any closer. So if this point was, let's say, really close to the line and I couldn't close the compass enough to make the arc, it's an easy thing to fix. I take the segment and I just extend it. I extend it out by some amount. Whatever distance I feel like will give me enough space to do what I need to do. So I'd extend it out this far, and then I'd go, okay, right there. That's the place I'm going to use to do my construction. I'm going to measure out to here. I'm going to make an arc. And now I have this point, and I can ignore this stuff on the side, and I can just do perpendicular bisector. I go to this point, I put an arc. I go to this point, I put the same arc. I connect. It's crooked, but it's freehand. We'll do it for real in a moment. I connect the intersections, and I get that. Here's what it looks like. And then the point I want to pass through, let's say it's right there. I would initially go to measure this and then go, uh-oh, I can't fit the compass here. Not a problem. Let me extend this. You could make it dashed, you don't have to make it dashed, you can make it solid, you can do whatever you want. As long as you extend this and you keep the line straight, you're just adding more to it, the line segment. I'm going to pay attention to that point there. So I'm going to measure my distance to this new endpoint. Use that, and I'll use that. Center the compass, open up more than half, and all we do is perpendicular bisector. Last step, put the line through the connection, and there we go. Perpendicular line, it is making a right angle. Here, it is passing through that point, and we did our construction.